The question is x, y, z are non-zero real numbers and the relation of x cos theta equal to y cos of theta plus 2 pi by 3 equal to z cos of theta plus 4 pi by 3 for some theta belongs to capital R, then show that. So let it be, it is equal to P. Then we can equate each and every term. X cos theta equal to P from this cos theta equal to P by X. Y cos of theta plus 2 pi by 3 equal to P. From this, we can write it as cos of theta plus 2 pi by 3 is equal to P by Y. Next, third one is Z into cos of theta plus 4 pi by 3 is equal to P. From this, cos of theta plus 4 pi by 3 equal to P by Z. What we can show that xy plus yz plus zx. For this, how we are getting means adding of these RHS. P by x plus P by y plus P by z. Then right hand side terms becomes cos theta plus cos of theta plus 2 pi by 3 plus cos of theta plus 4 pi by 3. Here taking P common from the left side of the terms, P into 1 by x plus 1 by y plus 1 by z, it is equal to the right hand side, we are writing it as 2 pi by 3 means that is pi minus pi by 3, 2 pi by 3. For 4 pi by 3 means we can write it as pi plus pi by 3. Okay. Here cos theta plus cos of pi minus of pi by 3 minus theta. If minus into minus plus we will get plus cos of pi plus pi by 3 plus theta, then that is 4 pi by 3 plus theta. So it is in the second quadrant, this is in the third quadrant. In the second and third quadrant, cos has negative. So it is cos theta minus cos of pi by 3 minus theta minus cos of pi by 3 plus theta. Then from the last two terms taking minus common, cos theta minus of cos of pi by 3 minus theta plus cos of pi by 3 plus theta. Here in the left side, we can taking the LCM yz plus zx plus xy by xyz. So P by xyz into yz plus zx plus xy. That is the left hand side terms. Here right hand side we can simplify it as cos C plus cos D. Cos C plus cos D is 2 cos of C plus D by 2, that is pi by 3 minus theta plus pi by 3 plus theta by 2. Cos of pi minus cos of A minus B by 2, that is pi by 3 minus theta is A, minus into the second factor is that is minus pi by 3 minus theta by 2. Here minus pi by 3 plus pi by 3 cancel. Here plus theta minus theta cancel. This is equal to cos theta minus of 2 cos of pi by 3 into 1 by 2. This is the 2 pi by 3. 2 pi by 3 into 1 by 2. 2 get cancelled. Cos of minus 2 theta by 2. Here 2 get cancelled. It is equal to cos theta minus 2 into cos pi by 3 value, that is 60. 60 value is 1 by 2 Cos of minus theta is, it is even function, it is cos theta. So this is cos theta. 2 ones are get cancelled. Here cos theta minus cos theta is equal to 0. This term is taking to right side, then yz plus zx plus xy is equal to 0 into xyz by p. It is equal to 0. So, therefore, xy plus yz plus zx is equal to 0. This is the solution. It is for 7 marks question. They will give in the 7 marks. If A, B, C are angles in a triangle, then prove that the first one is sine 2A minus sine 2B plus sine 2C equal to 4 cos A cos B cos C. Second one cos 2A minus cos 2B plus cos 2C equal to 1 minus 4 sin A cos B sin C. You have an idea about the formula sin C plus sin D formula, sin C minus sin D form, cos C minus cos D or cos C plus cos D formula, cos C minus cos D formula. Sin C plus sin D means 2 sin C plus D by 2 cos C minus D by 2. Sin C minus sin D is 2 cos of C plus D by 2 sin C minus D by 2. Cos C plus cos D is 2 cos of C plus D by 2 cos of C minus D by 2. Cos C minus cos D is minus 2 sin of C plus D by 2 sin of C minus D by 2. If you remember these 4 formulas, then you can easy to solve this given problem. The first solution is you can take the LHS. The LHS is equal to sin 2A minus sin 2B plus sin 2C. We are using here sin C minus sin D, and the sin 2C formula is 2 sin C cos C. If you get this is in the cos C relation, then easy to common the cos C from the 2. Okay, first we can solve it by using of sin C minus sin D form. That is 2 cos of C is 2A, B is D is 2B by 2 sin of 2A minus 2B by 2 plus 2 sin C cos C. It is equal to 2. Here 2 is taking common in the numerator and getting cancelled with the denominator. It is 2 cos of A plus B sin of A minus B plus 2 sin C cos C. Here ABC are angles in a triangle means in a triangle the angles, the sum of the 3 angles is equal to 180 degrees. Here you can write it as A plus B equal to 180 degrees minus C. Then here you can write it as 2 into cos of 180 degrees minus C in the place of A plus B equal to 180 degrees minus C. The second factor is as it is sin of A minus B plus 2 sin C cos C. Here 180 degrees minus C means that is in the second quadrant. In the second quadrant cos is negative, so it is minus 2 cos C sin of A minus B plus 2 sin C cos C. Now we can taking common from the two terms 2 cos C. Then it is 2 cos C into the sin C, right first, sin C minus sin of A minus B. Here we can write it as A plus B plus C equal to 180 means C is equal to 180 minus of A plus B. Now we can substitute here in the place of C sine of 180 degrees minus of A plus B minus sine of A minus B. In the second quadrant, sine has positive, so we can write it as sine of A plus B minus sine of A minus B. Again, we can apply the sin C minus sin D form, that is 2 cos of A plus B or C plus D, A plus B plus A minus B by 2 sine of A plus B minus of A minus B by 2. Here plus B minus B get cancelled. It is 2A, 2 get cancelled. It is 2 into 2, that is 4 cos C cos A. Here also A plus B minus A plus B. A minus A cancel, 2B, 2 cancel. We are getting sin B. It is equal to 4 cos A sin B cos C. That is equal to RHS. Therefore, sin 2A minus sin 2B plus sin 2C equal to 4 cos A sin B cos C. LHS is equal to RHS. It is the solution. Next question. If A comma B comma C are angles in a triangle, then prove that. First question is sin A minus plus sin B minus sin C equal to 4 sin of A by 2 sin of B by 2 cos of C by 2. Second one is cos A plus cos B minus cos C equal to minus 1 plus 4 cos of A by 2 cos of B by 2 sin of C by 2. This is the question. We can solve it by the previous, how we can doing that one, the same form. Here sin A plus sin B minus sin C, here 4 is there. Now I am explaining the second question answer. Taking the LHS is equal to cos A plus cos B minus cos C. Before of this, we can write it as in a triangle A comma B and C are angles. We know that sum of the angles is equal to 180 degrees. From this, A plus B is equal to 180 degrees minus C, and also C is equal to, we can write it as 180 degrees minus of A plus B. Okay, here the LHS is cos A plus cos B minus cos C. Here, observe this RHS term, sin C by 2 is there. So, we can write this cos C is equal to 1 minus 2 sin square C. Then we can easy to get the sin C by 2 is common from the using of cos C plus cos D form and this one. Just we can take the LHS is equal to cos C plus cos D is 2 cos of a plus b by 2 cos of a minus b by 2. Okay. Here cos c plus cos d means cos of a plus b by 2 cos of a minus b by 2 means here we can take a plus b by 2 180 degrees minus c by 2. So both sides we can apply the cos of a plus b by 2 is equal to cos of 90 degrees minus c by 2. If cos 90 means that becomes sin c by 2. So for taking the sin c by 2 we can make into cos c using of 1 minus 2 sin square c by 2. That is the form of cos 2c form. That is cos c equal to 2 cos square c by 2 minus 1 or 1 minus 2 sin square c by 2. Which one is suitable? Just we can observe from the first terms only. So here clearly we can write it as 2 cos of 90 minus c by 2 cos of a minus b by 2 minus 1 minus into minus plus 2 sin square c by 2. It is equal to minus 1 right front plus 2 common. Cos of 90 minus c by 2 is sin c by 2 cos of a minus b by 2 plus sin square c by 2. Sin c by 2 is also taking common minus 1 plus 2 sin c by 2 cos of a minus b by 2 plus sin of 1 c by 2 is there. That c by 2 can be written as 2 ones are 2 90s are c by 2 equal to 90 degrees minus of a plus b by 2. It is equal to minus 1 plus 2 sin c by 2 cos of a minus b by 2 plus sin of, in the place of c by 2, 90 degrees minus of a plus b by 2. It is equal to minus 1 plus 2 sin c by 2 cos of a minus b by 2. 90 minus theta is sin becomes cos of a plus b by 2. It is equal to minus 1 plus 2 sin c by 2. Again using the form of cos c plus cos d, 2 cos of c plus d by 2 cos of c minus d by 2, a minus b by 2 minus of a plus b by 2 whole by 2. It is equal to minus 1 plus 2 sin c by 2. Here minus b by 2 plus b by 2 get cancelled. Here we are getting a by 2. That is 2 cos of 2a by 2 into 1 by 2 cos of, here plus a minus a cancel, minus b minus b. It's minus 2b by 2 into 1 by 2. Here 2 get cancelled, here also 2 get cancelled. It is equal to minus 1 plus 2 2s are 4 sin c by 2 into cos of a by 2 into cos of minus theta is plus b by 2. So this is equal to minus 1, write in angle order, 4 cos a by 2 cos of b by 2 sin of c by 2. Therefore, it is equal to RHS. LHS is the cos A plus cos B minus cos C is equal to minus 1 plus 4 cos of A by 2 cos of B by 2 sin of C by 2. It is the solution. The question is, if A, B, C are angles in a triangle, that is nothing but immediately we can write it as A plus B plus C equal to 180 degrees. From this, what we want, A plus B equal to 180 degrees minus C, or C equal to 180 degrees minus of A plus B. What is the suitable? Then we can choose that one. Taking the first one, LHS, that is sine square A plus sine square B minus sine square C equal to 2 sine A sine B sine C. Cos square A plus cos square B minus cos square C equal to 1 minus 2 sine A sine B cos C. First, we can remember the formulas. Cos sine square A plus sine square B means that will come in which one? That is in the form of sine square A plus sine square B. Do you have an idea about that one? Here we cannot, but sine square A minus sine square B, we can write it as sine of A plus B into sine of A minus B. That is the formula. If the relation in between of two is minus is there, then we are getting that one. So here, what we can choose this in the place of B, we can first write the LHS sine square A plus sine square B minus sine square C. It is equal to, we can choose either B minus C or A minus C, whatever. If we cannot choose A plus B, why? Because that is not suitable. So here we can write it as sine square A is right as it is. Sine square B minus sine square C means that we can write it as sine of B plus C into sine of B minus C. Here it is in the B plus C means this is 180 degrees minus A, or C equal to this one. Here in the place of B plus C, we can write it as 180 degrees minus A. That is equal to sine square A plus sine of B plus C means that is 180 degrees minus A sine of B minus C. It is equal to sine square A. 180 minus A, sine is in the second quadrant is positive. So plus sine A sine of B minus C. In the two terms, taking common sine A into sine A plus sine of B minus C. It is equal to sine A. In the place of sine A, we can write it as A equal to B 180 degrees minus of B plus C. So sine of 180 degrees minus of B plus C plus sine of B minus C equal to sine A. 180 in the second quadrant, sine is positive, sine of B plus C sine of B minus C. It is equal to sine A. Sine C plus sine D is 2 sine of C plus D by 2. That is B plus C plus B minus C by 2. Sine of 2 sine C plus sine D. Cos of C minus D by 2. B plus C minus of B minus C by 2. Plus C minus C get cancelled, 2B, 2 get cancelled. We are getting the equal to 2 come outside, 2 sine A into sine B. It is plus C minus plus B plus C minus B minus into minus plus C, B get cancelled. 2C by 2 is 2. This sin C. Sorry, cos C. Okay. So it is equal to 2 sin A sin B cos C. So here the question is, it is cos C. Therefore, it is equal to RHS. Then we can write it as sin square A plus sin square B minus sin square C. LHS is equal to RHS is 2 sin A sin B cos C. It is the solution. Got it? Any doubt?